In example 5 here, we're going to roll one die and let y be the number showing on the die. We're going to calculate e not of y, but e of y squared. So really this is another test of finding the expected value of a function of a random variable. Let me remind you of the formula for that. The expected value of a function of a random variable, you calculate it quite similarly to the expected value for the random variable itself. It's p of y. Well, if it were the random variable itself, you'd just have a y here. But since there's a function of the random variable, you run it through g of y. And so in this case, our function is exactly y squared. And so we're going to add up all the possible values that could be showing and the probability of each one times y squared for each one. So if we were just finding the mean or the expected value of the variable itself, that would just be a y, but now it's y squared because of what the problem is asking us. So let's go ahead and think about all the possible values you could have. The possible values when you roll a die are 1, 2, 3, 4, 5, and 6. But if we run each one through the function, that means we square each one. Let me go ahead and square each one here. And then we put a probability on each one. So 1/6 times 1 squared plus 1/6 times 2 squared plus 1/6, 1/6 plus 1/6. I didn't give myself enough space here. Plus 1/6 times 6 squared. And of course, it's easier there to factor out the 1/6. So I'll put a 1/6 on the outside here. 1 squared is 1, plus 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared 25, and 6 squared is 36. And if you add those up, let's see, 36 plus 25 is 61, 16 is 77, 9 is 86, 4 is 90, and 1 is 91. So I get 91 over 6. As my expected value of y squared, or my mu for y squared. So that's really the end of that problem, but let me recap the steps here. We're using the formula for the expected value of a function of a random variable. I gave you that formula back on one of the early slides in this lecture, so you can go back and check that out. The difference between calculating the expected value of a function and the expected value of the original random variable means instead of y here, you just change it to g of y. So you're no longer talking about y, you're talking about g of y, which means that you're adding up the probabilities times, in this case we have our function is y squared. That's the most common function we're going to be looking at. And so in this case, we have y squared here. And so we take all our values and we square each one. 1 squared, 2 squared, 3 squared. These are all the values you can get by rolling one die. 5 squared, 6 squared. And the probability of each one of those is 1/6. So we multiply by 1/6. And now we just simplify the arithmetic. Square all those numbers, multiply by 1/6, and we get 91 over 6. This is kind of an early preview of something we're going to be doing in the next lecture. We're going to be looking at variance and standard deviation, and in order to calculate that, it's going to be very useful to calculate the expected value of y squared for a random variable. So that's why I'm giving you several examples this time of calculating the expected value of y squared, because we're going to be using that very often in the next lecture. So I hope this made sense to you. If it didn't, you might want to work it through a couple more times before you go on to the next lecture and learn about variance and standard deviation, because you really want to understand how to find the expected value of y squared first. So that's our last example for this lecture on expected values and means. Of course, expected values and means are the same thing. You are watching the probability lectures here on Educator.com. My name is Will Murray. Thanks for watching. Bye-bye.